Hi, what we're going to do here is have a look at the wheel alignment process. Okay, so let's review the order of operations. We want to make sure we do this in the logical order and get this done as efficiently as possible. So we're going to complete the pre-alignment inspection and any required repairs. I'm going to start the alignment machine, select the vehicle we're working on, mount the alignment heads, note the position of the wheels, whether you're going to be on the turntables or on the mark behind the turntables. So remember that is different depending on which machine you're working on. Perform the compensation following the on-screen instructions. Make sure you finish on the center of the turntables. Remember, we want to be on the center of the turntables. If we're not, things can go wonky when we try to do some of the adjustments and make some of the measurements. Okay, so this compensation procedure is sometimes called runout. So we perform the runouts. And remember that the heads must be recompensated if they get moved after this point. So if you knock a head and it moves, or you have to take a wheel or a head off, you have to recompensate that so that the measurements are accurate afterwards. Next, we're going to perform the caster swings. Just follow the on-screen instructions for that. That's the turn left and right thing to measure caster. The wheel brakes must remain locked for the duration of the alignment procedure now. So remember, following the on-screen instructions, I think step one is to lock the wheel brakes. The alignment machine will think the angles have changed if a wheel rolls from here on in. Okay, so all your readings should now be available on the screen. Okay, order of operations as far as adjustment goes. The first and second, I can't really tell you, which one's going to be first. Different designs do different things, but I'll adjust rear camber and toe as needed. This will set your thrust line. Most commonly, when you do the adjustments, it'll be camber, then toe. But it depends on what vehicle you're working on. Now, some vehicles have a rear caster adjustment. It's very rare, and it may not need to be done anyway. Okay, so third and fourth, front camber and caster need to be adjusted as required. Note that some vehicles don't even have the capability of adjusting caster on the front, but everything will have camber. Again, I can't tell you the order. It's going to depend on the style of the suspension system. Okay, some vehicles, you might have to move the engine cradle to get camber adjusted properly, and sometimes caster as well. So as an example, if I had slightly negative camber on one side and slightly positive camber on the other, in some cases then moving the engine cradle will correct that. And then the last step, remember the last thing we do is set front toe. Okay, so if we look at our specifications, we want to be clear that we know what we're looking at here. So you're going to get specified numbers for caster, camber, toe, thrust line, all of that. Right now, if you look at them, remember things will be color coded on the screen. So green is good, red is bad, yellow is fix it if you can, and gray is typically means there's no specification or no adjustment for it. You should always try to achieve the preferred angle. So you'll get a range of angles, right? And if we look at this chart down here, okay, so we see camber is good from 0.67 degrees and a plus or minus 3/4 of a degree. So that's the specifics of the camber adjustment, but we also have the right-left difference, or your cross camber. It has to be 3/4 of a degree or less, right? So we need to get our adjustments correct and the cross numbers correct as well. Okay, so adjustment types. Old school vehicles, we have one GMC pickup front end in the shop as the steering linkage demonstrator. And it actually uses this type of adjustment. You put shims behind a couple of bolts to move your upper control arms around. And depending on where you put the shims, you can get an adjustment at it. Now, this ends up working the same as cam bolts and things, but instead of rotating a cam, you're inserting or removing a shim. So let's just take a look at this for a second. So this is our upper ball joint. We're looking straight down at it. So there's our upper ball joint. If I added shims in both of these areas, the whole arm is going to move that way, and that's going to give me more negative camber. If I took the shims out of here, the arm moves this way, and it gives me more positive camber. And if I take shims from here, say if I took these out and put them under here, so now I've got a double-sized stack here, the result would be that this would move forward, and that would give me more negative caster. Remember, we're looking at the upper ball joint. If I took all the shims from here and stuck them all back here, this would move backwards. The arm would tip downwards, and that would give me more positive caster. So we're trying to accomplish the identical thing when we use cam bolts. It's just a lot easier to rotate cams than it is to get these shims in and out. Okay. An eccentric. So this is an example of that same type of system, but now we've got something a little more modern with cam bolts in it. And we loosen whatever the clamping fastener is, a nut, or it's typically a nut. You loosen the nut and then rotate the cam or the bolt, and you get the adjustment you need. All right. We have, in some cases, we've got it's kind of a two-step adjustment. So we've got an eccentric in the knuckle and to adjust camber, and then you set caster with an adjustable strut rod. So as of this video, we don't have a vehicle with a strut rod to show you. So I'll just give you a quick description. It's essentially a long bolt with a rubber bushing at each end, and we can more or less tighten or loosen that bolt to pull a control arm forward or backwards. Okay, so adjustment types. Again, we've got camber adjustment on a strut here. So this would be the strut to knuckle clamp bolts. This is very common on McPherson strut systems, a system like this. They can come from the factory with this installed, or we can install some aftermarket kits that accomplish the same thing. All right. In either case, what we're going to do is loosen the nuts that are clamping that together, and we will rotate the adjusting bolt. So the bolt will be attached to the cams that actually cause the camber change. Nice thing about this is this changes camber and camber only. It doesn't change caster at all. It will change toe, but remember, we're adjusting toe last anyways. Okay. In some cases, we've got adjustable plates at the top, so we can slide the plate inward or outward to adjust camber. And in some cases, they're pinned in place, so we have to pull a pin out or a rivet, and then we can slide a plate around at the top. And this is, again, on a strut system. So we can adjust the top of the strut to change our angles. Okay, again, very common that we have cams attached to links. These can be attached to upper control arms, lower control arms, toe links, front or rear. You can find them all over the suspension. Nice ones will have index numbers on them, so you can make very precise adjustments. If you know where you are, you want to change it like half a degree one way or another, you can just count the ticks on the cams. It works very nice. What I should note about all of these systems is you may have to unload the suspension. So you might have to lift the chassis up in order to take weight off of these adjusters so that you can actually rotate them. Some of these systems will be damaged if you try to rotate them with vehicle weight on them. There's an operation in the alignment machine where you can kind of record the settings as they are, tell the alignment machine you're going to lift it, then you lift it, you make your adjustments, lock everything in place, and set it back down again. Okay, and that's the most efficient way to do it a lot of times. Okay, full contact shims are available in some systems that don't appear to be adjustable at all, but you can pull them apart and you can get these indexable shims, so you can change the angle that they have in them, and you can rotate them so you can get whatever angle you need. This is with a semi-independent beam rear axle as an example. If you've got one that's a little bit tweaked, you have options like replace the axle or live with it, or you can pull it apart and put one of these shims in. These are not really they're not really enjoyed by a lot of alignment techs, because a lot of times when you go to do this, you run into other problems. So you'll find a brake line is rotten, and you'll have to replace brake lines, and you'll have seize bolts and things like that. So they're not commonly used, but they are available and they can solve a problem. Okay, toe adjustments. If you have a linkage type steering system, older ones tended to use a split sleeve with a clamp on it. So the sleeve would rotate on your tie rod ends, and it was either remembering it works like a turnbuckle, so one's right-hand thread, the other is left-hand thread, and when you rotate that, you make your tie rod assembly either longer or shorter. So you would loosen the clamp bolts, that would free up the split sleeve. Sometimes you had to apply some muscle to get that sleeve to free up. They're very often rusty. And then you rotate that sleeve to get the toe adjustment as needed, and then you tighten up your clamp bolts again. Other systems use essentially it's a nut about that long. One end's the right-hand thread, one end is a left-hand thread. So that would be what screws your hole or holds your two inner and outer tie rods together. And there would be jam nuts on there, so when you made your adjustment, you'd lock the jam nuts. In either way, you're just changing the length of your tie rod assembly until you get the place you need. With steering rack systems, typically we have our inner rod end encased in a bellows boot. You've got a jam nut and then your outer tie rod end. To make that adjustment, you loosen the jam nut and then make sure that the boot is not stuck on the inner rod end, because you're going to have to rotate that rod end in order to change the length of that assembly. So you might have to release a clamp and kind of wiggle the boot loose. And then once you get the adjustment correct, then you just lock your jam nut to keep everything where it was or where you need it. Okay, so toe adjustment. If both wheels are square to one another and the rest of the vehicle, the thrust line will coincide with the vehicle's center line. But if this is rear toe we're talking about. If rear toe is incorrect, one is set back slightly with respect to the other, you get an offset thrust line, and you get a thrust angle, and that causes a steering pull and all of that. So with rear-wheel drive vehicles that have a solid rear axle, changing toe is not easy. Some aftermarket parts are available to correct toe and thrust line problems on leaf spring vehicles. Essentially, it's a 2 or 3 piece shim assembly. You've got to release the U-bolts on the rear axle, and this assembly slides in there, and it offsets the pin location and everything, and it clamps in place after you get your adjustment made. If the axle is bent, there's not much you can do with it other than replace it. Sometimes the toe problem is caused by frame rails being shifted or chassis damage from a collision and things, and it might have to go to a collision bench to get it pulled back straight again. Camber adjustment on a solid rear axle. I know we're talking about toe, but we're talking about solid rear axles. Camber adjustment is not possible on a solid axle assembly. So if we're talking about live axle, like rear wheel pickup truck kind of thing. If you have a camber problem on that, the only solutions are live with it or replace the axle. Okay, so front toe, it's the last alignment angle to be set. So it's the same procedure on all vehicles, and I would strongly recommend we follow the Hunter Wind Toe procedure as it is laid out on the alignment machine. You go to your toe adjustment, select adjust with wind toe, and follow that through step by step. If you do that as it's written on the screen, you typically get a good toe adjustment. All right. Essentially, it is center the steering wheel and then adjust the wheels one at a time until they're pointed straight down the road. Okay. That's it. All right. We'll see you in class. Bye for now.